Hi everyone, we're now going to look at Chapter 5, which is a totally different subject. It's really a finance subject, and it's called time value of money. But it's necessary that we learn it because we do a lot of computations in accounting using the concepts in this chapter. So what is the time value of money? It means that over time, money will grow. Money will increase. So you invest $1 today, it's going to grow to a larger dollar amount in the future. Because we're always going to invest it in something with some type of a return, an interest return. You're not going to invest, hopefully, in something that will not have a positive impact on your cash. And that's the assumption here, that you're doing that. You're not gambling it, you're not putting it in the stock market and really risky stuff. You put $100 in the bank, it earns 6% interest. In 1 year, it's going to have a future value of $106. So the $100 today is called present value. That's what it's worth at time zero, today, when you put it away. And you don't have to go, oh, the beginning of the year. No, it's today. Because today is the beginning of the year that you're investing your money in. And 1 year from today is the future value amount. So, like I said, this is a very useful concept for determining the value of certain assets and liabilities actually. We have used what's called simple interest calculations so far in our discussions in accounting. Remember, interest is the amount of money paid or received in excess of the amount you borrowed or loaned. We've used simple interest, which says take your initial investment times the annual interest rate times the period of time you will calculate interest for. So if you had $1,000 invested for 3 years, 1,000 would be your initial investment, period of time 3 years, interest rate 6%, 1,000 times 6% would be $60. 60 times 3 would yield $180 of interest, simple interest. But in the real world, we don't use simple interest. We used it in the beginning of the accounting so that we could make our interest computations simple. But in the real world, we use what's called compound interest. And what this means is, at the end of each period that you earn interest, that interest is added to your investment. And then future interest is the next interest period will use that total initial investment plus any interest already earned to calculate the next future interest payment. So you're accumulating interest onto your initial investment. So your calculation gets a little bit more complex than the simple interest. Again, what is the simple interest earned each year on a $1,000 investment paying 10%? Well, on simple interest, you're only calculating interest on the initial investment. 1,000 times 10% times 1 year, $100 per year. When it's compound, you just won't calculate interest on the $1,000 initial investment. Take a look. Cindy Johnson invested $1,000 in a savings account paying 10% compounded annually. So the interest that was just earned will be added to the investment, or the amount that interest is currently being calculated on, for the next interest calculation. Because of that, and that'll happen every year, how much interest will she earn in each of the next 3 years? Well, she initially records a $1,000 investment. At the end of year 1, she will earn 10% on that $1,000. Her new balance, or her outstanding balance now, is $1,100. When we have compound interest, we now not only calculate interest on the initial investment, but any interest that has been earned so far. So her next interest, the second year, will be 10% times $1,100. So her interest will be $110 for the second year. Add that to her current balance of $1,100. It's now up to $1,210. For year 3, we will use the $1,210 current balance times 10% to get the third year's interest. Under simple interest, her interest would have been $100 each year. But when you compound interest, which just means adding all previous interests to your balance to calculate future interest, then you're going to see you yield $31 more. Her total interest would be $331. So we need to understand some information before we can start these calculations. We use the word effective rate or market rate to describe the actual rate at which money grows each year. So assume an annual rate of 12%. Okay. Now, depending on how often the amount is compounded will determine the interest rate for that period of time. What does that mean? All interest is stated in annual terms, 12%. But if your investment compounds semi-annually, then your interest rate will be 6% for the first 6 months and then 6% for the second 6 months. Now remember, if it's compounding annually, we're going to compute 6 months worth of interest, or semi-annually. You're going to compute 6 months of interest, add that to the balance at the end of the first 6 months, then compute 6 more months of interest at 6% and add that interest to the outstanding balance. If interest is compounded quarterly, so every 3 months or 4 months, every 4 months, we take the annual interest rate divided by the number of times it compounds a year. So each compounding period, its interest rate will be 3%. And if it compounds monthly and your annual interest rate is 12%, we need to get a monthly interest rate, 1%. So that's very important to do for these calculations. So we would need to know that. For instance, Cindy Johnson invested $1,000 in a savings account, paying 10% interest, compounded twice a year. What will be her investment balance at the end of the year? So, first let's do that. Take the initial deposit of $1,000. The annual interest rate is 10%. So every 6 months we will calculate interest using 5%. 5% times $1,000 is $50. So the first 6 months she earns interest of $50. She adds that $50 to the $1,000. This new balance of $1,050 is what will be used to calculate the second 6 months of interest. 5% times $1,050 will be $5,250. So her total interest is $102.50 for the year. The effective annual interest rate will be the amount of interest she earned for the year divided by the original balance at the beginning of the year, which was $1,000. So how much interest did she really earn because of the way this was compounded? 10.25% on her $1,000. Why is her effective annual interest rate higher? Because the second interest computation wasn't just calculating interest on the $1,000, but the $50 that was earned for the first 6 months. So when you compound, your effective rate, what you're actually earning, is going to be higher if you're compounding more than once a year. Jacob Lee invested $600 in a savings account paying 8% interest. It's compounded twice a year. What will be his investment balance at the end of the year? Well, $649. Again, take his initial deposit of $600. So after the first 6 months, how much interest did he earn? 600 times 4%. Remember, we take the 8%, divide by 2, $24. So his new balance at the end of 6 months is $624. It's that new balance we use to calculate the second 6 months of interest. $25 was the amount earned for the second 6 months. Add that to the prior balance, so he has $649. Now, that is the concept behind what we're about to do. You saw what we did in those slides. We had to start with the initial investment, calculate the first interest payment, calculate the second, calculate the third. What an inefficient, tedious process. That just takes too long. So instead, we have a couple different ways we use to calculate these amounts. I'm going to give you a pause 1 second. Okay, you probably didn't even notice I was gone for a minute, but we can calculate the amounts we're about to look at in various ways. The first way is do it the long way, like you just saw. Takes too long though. Takes way too long. The second way is in the very, very back of your book. There's tables. They start on P1. And these tables can be used in our course anyway to calculate the different items we're about to look at. Another item that can be utilized is a financial calculator. You can download an app, but if you have a TI-83 with an apps function on it or a calculator with an apps function, you'll be able to do these calculations. So let's take a look here. What are we calculating? Future value of a single sum. Cindy Johnson invested $1,000 in a savings account for 3 years, and the savings account pays 10% interest, compounded annually. So they calculate the interest for a year, add it to the outstanding balance, calculate the next year's interest. So there's a picture of that. What does it say? Remember at the very beginning, first slide, we said $1,000 is its value right now, present value, 0. That's when she invested it. We want to know what's it going to be worth 1 year from today, whatever today is, or 3 years from today. How much will it be worth at the end of 3 years? So as we said, we could do this long, like, okay, calculate the interest for the first year, add it, calculate the interest from the second year, add it. And so like maybe for 3 years, it's not a big deal. But what if that was 30 years? You'd be sitting here calculating that all day, unless you could hurry up and put it in Excel. But there's a quicker, easier way. On page P1, you see it says their present value and future value tables. And table 1 says future value of $1. And here's what this table is telling us. If you know your interest rate that will be used each period to calculate interest, and you know the number of periods that you will calculate interest for, then use this table. Across the top are interest rates, across and going down the left column is the number of periods. Now, number of periods doesn't mean years, and interest rate doesn't mean annual interest rate. Now, in this case, it will, because our interest rate is only compounded once a year. But if it was compounded more than once a year, say it was semi-annual, we would divide that 10% by 5 and use the 5% column. Okay? So what this table is telling us is if you have an investment that has a 10% interest rate compounded annually, I'm going to go to the 10% row at the very top, and it's compounded for 3 periods, go down 1, 2, 3, that $1 will be worth $1.331 at the end of the 3 years. So this is just telling you the future value of $1. Well, Cindy invested $1,000. So she wants to know what's its value at the end of 3 years. Well, there's our table. 10%, 3 periods going across. Just multiply the dollar, the 1,000, times 1.331. Pretty simple. The future value is $1,331. So this is one way of doing that calculation instead of going through that long process. Another way, if you have a financial calculator, as I said, it will have a blue, maybe apps button on it. You push the apps button. Oops, first make sure it's on, right? The apps button, and it'll come up as applications. You'll see finance, CBL/CBR, and a couple other things. You want to click number 1, finance. So hit the number 1, and then you want TVM solver, because that stands for time value of money solver 1. And you're going to see a bunch of variables. N is the number of compounding periods. So how many times does this money compound? Well, 3, right? 3 years, once a year. The next is interest rate. So you'll use your arrows up in the top right corner to navigate. I percentage. Put it in as a whole number. So we want to put the interest rate it will compound to each period. Well, it compounds once a year, 10%, so it's going to compound at 10%. What is the PV? What is the money worth today? Present value, 1,000. The PMT should be 0. That has nothing to do with this calculation. What you want to do is now arrow your way down, using the arrows in the right-hand corner, to the FV, future value. Your PY should be 1, CY should be 1, and the PMT end or beginning, it doesn't matter what's there. So now we want to solve, but we just don't hit enter. To solve, you should have a alpha button. Mine's green, a green alpha, and then enter. And you'll see it comes up as a negative. And that's just a little caveat of the financial calculator. And it looks at it this way. If you're putting money in at 1,000, you're taking it out. So it doesn't mean it's negative money. It just represents that it's being taken out at 1331. Okay, so that is a positive 1331. It's just your financial calculator calculates it because of that little caveat in it. So you could use the tables or the calculator. You can also download a financial application from, there's all kind of free apps out there. Oliver Kim invests $5,000 in a bank account, earning 8% interest compounded annually. How much will he have in his account in 4 years? Now they tell us the future value of $1 at 8% for 4 years is this much. So first you have to think to yourself, what am I trying to find out here? Oh, I'm trying to find out future value. How much is this $5,000 that I'm putting away today going to be in the account? How much is going to be in there at the end of 4 years? If the interest rate it's earning is 8% and it compounds once a year, well, then I want to solve for the future value. So I'm going to use the future value of $1 because I'm investing $1 basically. I'm making one investment and then I want to see what that one investment will be in the future. So I'm going to go to my 8% column on page P1 and I'm going to go down 4 periods, and my factor is 1.36049. Well, multiply 5,000 times 1.36049 and, well, isn't that wrong, right? I think, let's see, I'm going to put this in my financial calculator because something ain't right there, right? So, is the calculation wrong? Where's the answer wrong? N is 4, I is 8, present value is 5,000. I'm just putting these numbers in my financial calculator and navigating with my arrows on the right-hand side. I go down to future value, make sure the cursor is blinking there, alpha, enter. And the correct answer is 6,802. So the answer key there is wrong. It should be D. It should be D. And also if you take 5,000, to get out of your financial calculator, I have to hit my second button. It's up in the left-hand corner, and then the mode button, which when you hit second, it's the yellow, and quit. And that'll take me back to being on a regular screen. So if I take 5,000 times 1.36049, 6802. Well, We can calculate the present value or future value, but we could also calculate present value. Now, why would we do that? Well, there's your formula. If you're into using formulas, the future value is determined by taking the present value, in our last example, 1,000 or 5,000, I think it was, plus the interest rate of 4%, 0.04. You would use 0.04. No, I'm sorry, 0.08. 8% it was, right? 0.08 to the fourth power. N is the number of periods, so it would be to the fourth power. So if you could do that calculation, this is what I had to do back in my day. I used tables in that formula because we didn't have these fancy financial calculators back then, or the Excel to do our calculations. And Excel has all these formulas. If you are pretty good with Excel, you could check these out and do your calculations there. But the present value is found by taking future value. So we either know present value or we know future value. In our first case, we knew present value. That helped us to calculate future value. In this case, we know future value, and we divide that by 1 plus the interest rate to the nth power, to the period power. So in our last example, it would have been the 6802 divided by 1 plus 8.08 to the fourth power. The good news is you don't have to use those formulas, but they're great to know that they're there. And there was your calculation. This bottom formula, the 1 plus I to the nth power, that is your formula in future value. Pretty cool, huh? Remember the 1.331? But let's say we need to determine the present value of 1331 that was received at the end of 3 years when the interest rate is 10%. Now guys, if you draw a timeline, the very end of 3 years, we have a value of 13. So let's say we said we need to have $1,331 in this savings account at the end of 3 years, and the interest is going to be earned on it at 10% each year. How much do we have to invest today? So we're trying to figure out present value. So what we do is we say, well, we know what we need, 1331. Now go to P2. P2. You're going to go to the 10% column, go down 3 periods. So $1 in 3 periods at 10% interest is worth 0.75131 cents at time 0. So if you multiply that 0.75131 times the future value times that dollar in the dollar future, 1331, you would have to invest $1,000. So if you're sitting there saying, well, we already know that. I know, but let's say we didn't. So we could say we have $1,000 today. We can invest it at 10% for 3 years. How much will we have? Or maybe the question is, we need this much money at the end of 3 years. If it's invested at 10%, what do we have to put away today to get there? So it's just answering those kind of questions and the calculations you can use to do that. So due to the time value of money, given a choice between 1,000 now and 1,000 in 3 years from now, you would choose to have the money now so that you can invest it and earn interest on it. Given $740 now and 1,000 in 3 years from now would depend on your time value of money. So if you want a 10% return, you would choose the $1,000 in 3 years because the present value of $1,000 to be received in 3 years at a 10% interest rate. So what are we doing here? We're saying we know we're going to get $1,000 in 3 years. What is that money worth today? If we invested that at 10% for 3 years, what amount would we have invested today? Well, 10%, 3 years, 0.75131. Okay, this is one way. All right, so if you take that, go into your financial calculator, or you can use the 1,000 times 0.75131. Okay, you would have to put away $750. Okay, or it's worth $750 today. Well, what's your other choice? I could get $740 now. Oh, wait, but that $1,000 in 3 years is like getting $750 today. Oh, I'm taking the $1,000 in 3 years. What if your time value of money rate is 11%? Well, let's see. Now take the $1,000, times 11% 3 periods, 0.73119. I'm just doing it a little bit different than what your slide is. Oh, what's that $1,000 worth today if the investment is at 11%? Oh, it's only worth $731. So I'm going to take $740 at time zero. Because if I wait and take that $1,000 in the future, it's only worth $731 today. I know that's confusing, but that's how we look at it. So whenever we're trying to make a choice, we don't compare present value to future value. No. If you know present value of one item and you know the future value of the other, you could either convert the future value back to present value, and that's what I did. I said, what's that $1,000 worth today given those two scenarios? What your author chose to do was determine what the future value of today is. So they did the opposite. They said it's worth $740 today. If I invested at 10% for 3 years, they used table 1 because that's what is used to determine future value, and multiplied 10% 3 periods 1.331. That will only accumulate to $985. So why would I take $740 today? I could take $1,000 in 3 years. They did the same thing with the $740 and said, okay, instead we're going to have it invested at 11%. Now that's a little different. Now your factor is 1.36763. So what's that $740 worth in 3 years if it's invested at 11%? Oh, now it's worth $1,012. So yeah, I'm going to take the $740 today and invest it at 11%. It's worth more than just receiving $1,000 in the future. So again, our relation between the present value and future value. Present value is today, times zero, whatever time zero is. It could be October 7th. Future value is October 7th in 3 years. Okay, so it's not saying calendar year here. Future value requires the addition of compound interest because that $1 is always worth more in the future because of interest, where present value requires us to remove interest. We know what it's worth with the interest at the end of 3 years, so we've got to remove the interest component to find out what we need to invest to get to that point. Versatile Company, purchased a delivery truck on February 1st. The agreement required Versatile to pay the purchase price on February 1st, 2022. Assuming an 8% interest rate, to calculate the price of the truck, Versatile would multiply $44,000 by, so sometimes this happens. Okay, now what do you remember? They don't say, here's how much this truck costs. They just say, give us $44,000 in a year. Well, what is that $44,000? It's a future value. We're paying that in 1 year. We want to know the present value of that $44,000. because included in that $44,000 is principal and interest. So we'll take the $44,000, 8% interest rate we need to look at. We're going to go to the present value of one table. 8% interest rate 1 year. So I'm going to do the calculation, but it would be answer B. So how much is that truck really being purchased for? 44,000 times 0.92593, $40,741. And it's that amount we would record the truck at. So there's one example of when we might have to use this type of calculation in accounting. Sometimes we may know present value and future value, but we may not know the interest rate or the number of periods. So suppose a friend asks to borrow $500 today and promises to repay you $605 2 years from now. How much interest are you really earning on that? Well, we know present value, we know future value, and we know how long. We know the number of periods too. So we want to figure out the I. And there's one of two ways of doing that. You can use the present value of one table. When you do that, you'll take 500, you'll take the present value divided by the future value because it's algebra. 500 equals 605, the future value, times the present value of the interest rate. And we've got to figure out the interest rate. So if you take 500 divided by 605, you'll get an answer. But that's not your interest rate. That's the factor you have to look for on the present value table, 0.82645. Oh, okay. And how do you find that? Well, we know how many number of periods there are. So we'll go to the second row and we'll just go across until we find a number close to our result. And that's in the 10% column. So the interest rate is 10%. You want to invest $10,000 today to accumulate $16,000 for graduate school. You can invest at an annual interest rate of 10%. So here you know the interest rate. How many years will it take you to accumulate that amount? You go about it the same way. You know the present value. You know the future value. You know the interest rate. You just need to figure out how many years. So, again, if you use present value, 10,000 equals future value times your factor from the table. 10,000 divided by 16,000 gives us 0.625. We know the interest rate, 10%. So go to the 10% column on table 2. Oops, I'm on the right. Table 2. And go down until you come to a factor of around 0.625. And it looks like it's very close, a little bit off, but that's okay, just as long as you're close, to 5. So it will take 5 years approximately. So that's how we use it. So monetary assets include money and claims to receive money in the future, the amount of which is fixed or determinable. Cash and most receivables. Monetary liabilities are obligations to pay amounts of cash in the future, the amount of which is fixed or determinable, like notes payable. So let's take a look at some of these techniques for these. So some examples of when you'll use present or future value calculation in accounting. The Stridewell Wholesale Shoe Company manufactures athletic shoes for sale to retailers. Okay. The company recently sold a large order of shoes to Harmon Sporting Goods for $50,000. Stridewell agreed to accept a note in payment for the shoes requiring payment of $50,000 in 1 year. In addition, they're going to pay 10% interest. So, the company is going to receive $55,000 in 1 year. That's at a 10% interest rate, 1 period. So what is the present value? So 10% times 50,000 was a $5,000 interest. Well, if you take 55,000 times the present value at 10% one period, because we know the future value, we're trying to figure out the present value, it's the $50,000. 0.90909, and this was from table 2 on page P-2. Now I've kind of abandoned our financial calculator, so let's go back to that. I'm hitting the apps button. I'm going back into finance, TVM solver. So now my N is 1. My interest rate is 10. My present value will be 0 for now, and I'll use my arrows to go down, and then my future value is 55,000. I'm going to use my arrows on my right-hand side of my calculator near the top to go back up to PV, make sure the cursor is blinking over it, and then I'm going to do alpha, enter, and it'll give me 50,000. So there's the table. The Stridewell Wholesale Shoe Company sold a large order of Harmon Sporting Goods to Harmon Sporting Goods. Terms of the sale: a non-interest bearing note, which there's no such thing as no interest. It's just there's no interest directly stated on the note, of $60,500 with payment due in 2 years. So future value we know, $60,500. We know it's due in 2 years. Okay. We know normal interest, and it should state here that interest on these types of notes is usually at 10%. So now we're going to go to our present value of one table, table 2, 10% interest, 2 periods. So 60,500 times 0.82645. And there you go. And there's our calculation. The present value is 50,000. So if you noticed in that second, it didn't tell us how much they sold them for. It just said you're going to get 60,500 in 2 years. It was up to us to determine what is their value today, because that's what we record the sale at, not what we're getting in the future, what we're getting today. 50,000, or what they're worth today. Turpentine Distilleries considering investing in a 2-year project. Okay. The company's required rate of return is 10%, so they expect a 10% interest rate. The present value of 1 for 1 period at 10% is 0.909 and 0.826. So those are the factors right from the table, from the 10% column, first period, N is 1, N is 2. The project is expected to create cash flows of $240,000 in the first year and $300,000 in the second year. The distillery should invest in the project if the project's cost is less than or equal to. So now this is a little more complex. So what we need to do is first determine what's the present value of the $240,000 at the end of the first year. 1 period, 10% interest. We'll use the 0.90909. So 240,000 times 0.90909. So the present value of that future payment, $218,182. We're going to do the same calculation for the $300,000 we're going to receive at the end of 2 years, 2 periods. So we want to know what's its value today, that $300,000. So we'll use the 0.826, 10%, 2 periods, and you get 247800. So we're going to add together the result from our first calculation, which was 218,182, plus the result from our second calculation, 247,800. And we get 465,982. And that's our answer. It's close. So only if our investment is less than the present value of those two amounts we're going to receive from the project do we actually take it on. And there it is again. I was off a little bit, I guess, on my first one. In basic annuities, now this is a different type of calculation. In our prior calculations, the assumption was there was one amount at time zero, present value, and then one amount at the end, future value. So that's why we say future value of $1, present value of $1. This next type of calculation is when there's more than one payment. And we call it annuities. An annuity is just a term. That's all it is. It's a term we use to describe a series of cash flows at the same amount, either they're being received or paid over the same time period. So it's just a term used to describe that. So we're not saying it's a retirement plan. No, this is just a word, and that's all an annuity is. It's a word used to describe a series of cash flows of the same amount at the same period of time. Some examples. A loan on which periodic interest is paid in equal amounts. A lease, so a rent, paid in equal installments during a specified period of time. Same amount, same time period. So it'll be maybe $1,000 every year. That's an annuity. Or $1,000 every 6 months. $1,000 every 3 months. Same amount, same time period. Now, we have two different types of annuities, and they are defined by when the payment occurs. Does it occur at the beginning of the time period or at the end of the time period? So if the cash flow, so if the payment has to be made or the payment is received at the end of each time period, it's an ordinary annuity. If the cash flow, you're either receiving money or paying money at the beginning of each period, then it's an annuity due. So if you are to receive payments every 6 months, if you receive the payment at the beginning of every 6 months, so you actually get a payment at time zero, because that's the beginning of the first 6 months, that's an annuity due. If the payments start at the end of the first 6 months, that's an ordinary annuity. And I know that's confusing, and I'll try to point that out as we go through here. That always hung me up when I was learning this. So let's look at an example of an ordinary annuity. An installment note payable is dated December 31st, 2021. So that's time zero. It's the same as saying 1/1 of 2022. It might require the debtor to make 3 equal annual payments, with the first due 1 year from today. So today is time zero, December 31st, 2021. Don't look at it and go, oh, it's the end of 2000. No. This note is dated today. So today, December 31st, is the beginning of the first year of this note. The first payment is not due until December 31st, 2022, the end of the first payment, or the first period, the end of the first year, the end of the second year, and then the end of the third year. That's what makes it an ordinary annuity. When does the payment occur? Let's say instead you have a 3-year rental lease of a building that begins December 31st, 2021, and the lease time ends December 31st, 2024. That requires the first lease payment to be made December 31st, 2021, today, the first time zero. So that means it's being made at the beginning of each year. So that makes this an annuity due. And that's important because it will influence your calculation. So if you have a set of present value tables, an annual interest rate, the dollar amount of equal payments made, and the number of semi-annual payments. What other information do you need to calculate the present value of the series of payments? Wow. Oh, really? The timing of the payments. How often? And it looks like they're semi-annual. Oh, I'm sorry. Yeah, you need to know, do they happen at the beginning or the end? See, I looked right over that. But you need to know that. Just an investor wants to calculate how much money he needs to deposit today into a savings account that earns 4% in order to be able to withdraw $6,000 at the end of each of the next 5 years. He should use which present value concept? Wow, we just threw you right into annuity calculation. I'm not too comfortable doing this, but I'm going to explain it, but then we're going to go through some slides here. So what this is saying is, what's the value? What is the value today of those $6,000 payments, withdrawals, that are being made at the end of each of the next 5 years? So if he needs to put money away today in order to get that $6,000 at the end of 5 years, at the end of each year for the next 5 years, what is the lump sum what is its present value? What are those $6,000 in future payments worth? Well, the first question is, what is the interest rate? 4%. And and I know that because the withdrawals will happen at the end of each of the next 5 years. So they're an annual withdrawal. So the payment is happening, that $6,000 is happening annually. So I'm going to leave it at 4%. What's the number of payments or periods? It's the number of withdrawals in this case. Once a year, 5 years. So we're going to have a 4% interest rate, and our N, or periods, will be 5. How do we calculate the value? Well, the good news is we have tables, and they're back at the end of the appendix. P4. We want to know what is the present value of those $6,000 payments of the annuity. What type of annuity? An ordinary annuity. How do I know that? I know it's an ordinary annuity because the payments start at the end of each of the next 5 years. Justin isn't taking anything out today. He's starting at the end. So he would look at the present value of an ordinary annuity of 1 for 5 periods. Now, if you're saying, why don't we just use the present value of 1? Well, he doesn't want to know how much is one $6,000 withdrawal worth today. He wants to know what 5 each annual withdrawals are worth today. So if you take 6,000 times 5, that's $30,000. But remember, what's included in that $30,000? Interest. So we're pulling out the interest in each of those $6,000 payments and bringing it back to determine its value today. So how much would he have to invest? Well, we're figuring this one out, right? So we would go into the 4% column and go down 5 periods. And I get 4.45182. Multiply that by the payment, the PMT payment, 6,000. How much is he withdrawing? That's considered his payment. So he would have to invest $26,711 today at time 0 in order to withdraw $6,000 at the end of each year for the next 5 years. Now, if you're saying, well, he's going to take out 30, I know. The difference between what it's worth today and that $30,000 he ultimately takes out is the interest. So we're pulling out the interest in each of those $6,000 payments and bringing it back to determine its value today. So how much would he have to invest? Well, he's going to take out 30, I know. The difference between what it's worth today and that $30,000 he ultimately takes out is the interest. So instead of us doing crazy complex calculations, just use the table. If you're using your financial calculator for this, you hit your apps and then Finance 1, TVM Solver. N would be 5 for the number of payments or number of withdrawals. I is 4 since the withdrawals happen annually. We want to solve for PV, so we're just going to make that 0 for now and move our cursor down using our arrows in the right. Future value has nothing to do with this calculation, so we want to make sure it is at 0. But the PMT is very important when calculating an annuity because it's that we're trying to determine the present value of in this case. So what's that $6,000 we want to withdraw worth today? The other key thing when calculating an annuity is that the bottom item, sorry, I'm getting text messages, so I'm just going to shut that off. The bottom where it says PMT and you see end or beginning, now it's imperative. If it's an ordinary annuity, the PMT happens at the end. So you've got to make sure that's highlighted in your calculator, and you could do that by using your arrow keys in the right hand corner. If it's an annuity due, you have to make sure that you transfer the cursor over to begin and hit enter, so that will be the highlighted item because the payments happen in the beginning of each time period. But this is an ordinary annuity, so we'll make sure the end is highlighted. And then using my arrow keys, don't worry about CY and PY, just make sure they're at 1. And I'm going to go up to PV and solve. Alpha, enter, and there's my $26,711. Take a look at this. Not Worth Getting Consulting Company purchased a machine for $15,000 down. So today, at time 0, they put $15,000. Okay, so that definitely is part of the cost of this machine. They're going to pay $500 a month at the end of each month for the next 36 months. How would the company calculate the price of the machine today, assuming the annual interest rate is known? We don't take the present value of $18,000 in A. No. That's like saying you're going to pay $18,000 at the end. No, you're paying $500 a month each month, and interest is compounding on this loan each month. So what we're going to do is take the $15,000 plus the present value. Let's look at B. Annuity due. No, annuity due is when these $500 payments happen at the beginning of each month. They're not. They happen at the end of each month. So we're going to take the $15,000 cash payment plus the present value of an ordinary annuity of $500. That's our same cash flow that happens every month for 36 periods, because our periods equal the number of payments. Also, it says our interest rate is known. If we have an interest rate, let's say of 12%, since these are monthly payments, we would divide that by 12, and our interest used in our calculation would be 1%. So be careful of that, because the compounding period is the same as the number of payments. So it's monthly. You've got to transform your annual interest rate into a monthly interest rate. And there it is. Okay, so that's present value of an ordinary annuity. I want to take out money, $6,000 a year. How much do I have to invest today? We could go the other route and say, if we put $6,000 away for every month for the next 5 years, how much money will we have at the end of 5 years? Now we're calculating future value of these payments. And that's ordinary annuity is just those payments. Rita Grant wants to accumulate a sum of money to pay for graduate school. Rather than putting one amount today and letting it sit there and see what it's worth in the future, she decides to put away $10,000 a year over the next 3 years in a savings account, paying 10% interest compounded annually. She decides to make the first payment to the bank 1 year from today. So she's making her payments at the end of each year. At the end of this year, okay? Because today is time 0, 1 year from now is the end of year 1. So what we want to do is say, okay, what are the payments? $10,000 a year at the end of each year. We want to know what those 3 $10,000 payments will be worth at the end of 3 years, assuming there's a 10% interest rate. If you go to, let's see if there's a page P3, at the end, there's a table. This is an ordinary annuity, but we're not trying to figure out how much are those $10,000 payments worth today. We're trying to see how much you'll have in the future. So we're going to go to our 10% column, 3 down, 3.31. So we're going to multiply the $10,000 times 3.31. She'll have $33,100. So they do the actual calculation there. I'm using future value of 1. No, I want you to use the table on page P3. Avoid what's on the bottom. Just look up 10%, 3 periods, 3.31 times the payment of $10,000. Those payments will be worth $33,100 in the future when she wants to cash it in for graduate school. And there's them using the table, which I prefer. That was okay to explain the stuff in the beginning, but now I think we're getting accustomed a little bit to using these tables. Remember, our N is the number of payments or withdrawals, depending on the type of situation you're in. Now, we've been working with ordinary annuities where the payments begin or the withdrawals begin at the end of each year. What if instead she made the first payment on this today? So at time 0, she put $10,000 away, and she's going to put $10,000 away at the beginning of year 2 and at the beginning of year 3. And if you're sitting there going, well, it says end of year 1. Well, the end of year 1 and the beginning of year 2 are the same time. Same with the end of year 2 is really the beginning of year 3. So we're looking at that first payment. When did that happen? It happened the beginning of year 1. So that makes this an annuity due. There's a table. So we want to know if she starts making the payments at the beginning of each year, what's the future amount that will accrue or be in that fund? 10% interest. Oops. Future value of a annuity due is table P5. 10%, 3 periods. Your factor is 3.6410. So we would take 3.6410 times 10,000. So if she just changed her payments to the beginning of each year, she would accrue or have at the end, her future value would be 36,410. Now if you're looking there going, whoa, whoa, whoa. Just from switching the payment from the end of the year to the beginning of the year, she could incur almost $3,000 more in interest? Yes. Because the money is sitting in the account longer if the payments are made as of the beginning of each year. And that last payment is actually earning interest. Remember, an ordinary annuity, if you look back at the slides, the last payment was made at the end of year 3. It doesn't get any interest on it. And that's why. The Stinch Fertilizer Corporation wants to accumulate $8 million for plant expansion. The funds are needed on January 1, 2026. Stinch intends to make 5 equal annual deposits in a fund that will earn interest at 7% compounded annually. They're going to make the first deposit on January 1, 2021. So let's make a drawing. The first deposit is to be made on January 1, 2000, present, future, past. What is the amount of the required annual deposit? So they want to accumulate 8 million, so we know that's a future amount. The funds are needed as of January 1 of 26. So I'm drawing a little timeline, and I put 1 of 26 all the way to the right. They want to make 5 equal installments. And there's the 25, 24, 23, 22, and 21. The first deposit is to be made on January 1, 2021. So there's the first one on my little timeline right above 2021, January 1. I put 1. And then the second one will be made January 1st, 2022. The third one, January 1st, 2023. The fourth one, January 1st, 2024. And the fifth one is January 1st, 2025. So when I look at that, they want to know what will it be worth January 1st, 2026. This is an annuity due. Each payment, the payments are being made at the beginning of each period. The beginning of 2025, and the amounts will be invested starting, like I said, the beginning of each period. So this kind of problem could get confusing because of when the payments are being made. So don't go 21 minus 26. Oh, it's an ordinary annuity. No. Okay. If there was a payment being made on January 1 of 2026, this would be an ordinary annuity because the payments would have been made at the end of each period. The first payment would have been made January 1, 2022. But since the payment was made at the beginning, okay, 1 of 25, which is the beginning of the 5th year, it's an annuity due. So please let me know if you have any questions on that. So our calculation will be 8 million divided by times the factor future value. Wait a second. Okay. We want to know our payments. That's the future value is 8 million. Now I'm getting myself confused. Future value of an ordinary annuity. So let's go to that table. Future value of an ordinary annuity. Okay. So we want to determine the payments. Usually to determine the future value, what do? We take payment times amount from the table. So I'm going to go to future value of an annuity due table, which is table 5. I'm going to look up 7% interest for 5 periods. And my factor is 6.1533. I don't multiply that by 8 million because my payments aren't 8 million. My future value is. So to determine the payments, I take 8 million divided by the factor of 6.1533. So my annual deposits are 1,300,800. I'm doing some. Oh, they gave us a different factor. Jeepers creepers. Hold on. Sorry. 7%. Did I use the right column? for 5 periods. Oh, they just use 6.15. So if you take 8 million divided by 6.15, they didn't use all of the other positions. 1,300,813. I'll get it out. Okay, but if you use the factor in the table, it would be a little different because there's more, it's more precise using those decimal positions extended out. Okay, so that was a good one. So you could really see what an annuity due is. IR Wright plans to make quarterly deposits of $200 for 5 years into a savings account quarterly. The first deposit will be made today, immediately, right now. When that says that, it's an annuity due. The savings account pays interest at an annual rate of 8% compounded quarterly. How much will Wright have accumulated in the savings account at the end of the 5-year period? Well, first of all, we know this is an annuity due, and we're trying to figure out, are we calculating present value or future value? Well, they want to know what it'll be at the end, so it's future value. So if you're using your table, you'll use future value of an annuity due. We know the payment. The payment is $200 a month for 5 years, or I'm sorry, $200 a quarter for 5 years. So we need to calculate how many payments will be made, the N. 5 years times 4 a year, each quarter, there'll be 20 payments. So N is 20. How much is the I? Well, annual interest is 8%. It will compound 4 times or quarterly during the year. So divide the 8% by 4, 2% is your interest. So if you're using your future value of an annuity due table, you want to use your 2% column for 20 periods. They're a little bit, yeah, it's a little bit different than what's in the, no, they put the wrong factor there. Unbelievable. It should be 24.7833, not 24.2974. Someone used the 24 from one and then the decimals from another. So that should be 24.7833. So take the $200 in payments times that factor of 24.7833, and you should get 49.56. Since they use 24.2974, it's a little different, but they're wrong. Your answer should be 4957. Now let's take a step back and take a look at our calculator. If you go into your apps, if you have the finance calculator, click 1 for finance, 1 for TVM solver. In this case, your N will be 20, your I is 2. You are not solving for present value, so make that 0 and use your arrows to go down. Your PMT should be 200, and you're going to calculate for future value. But be careful, you are calculating for annuity due. You want to arrow down to where it says PMT and make sure the beginning, the word begin, is highlighted by using your arrows and enter. Now you can arrow back up to future value. So make sure your cursor is blinking over future value, alpha, enter, and you'll get 49.56. If you left that cursor over the word end, it would have calculated the future value of an ordinary annuity, which we saw in prior examples can be vastly different because of when the payment was made. Wow, there's a lot of great examples here. UB Wong plans to make quarterly deposits of $200 for 5 years into a savings account. That's the same one, isn't it? Yeah. So, oh no, They changed it up. Now the deposits will be made at the end of each quarter. So now we just changed our annuity from an annuity due to an ordinary annuity. Different table. So now we're going to use the future value of an ordinary annuity. So we're going to have the same interest rate because it's 8% 4 times a year. So now it's 2%. 20 payments of $200. So we'll use 2, go down 20. Oh, now it's the correct future value, 24.2974. 200 times 24.2974. Am I in the right thing? What are they doing here? 2% future value of an ordinary annuity. I think this is a little jazzed, guys. Hold on one second. They're using the wrong amounts here. What the heck they're doing? Somebody was way off. Let's calculate this ourselves. According to our future value of an ordinary annuity, 2%, 20 periods, our factor is 24.2974 times 200. The answer is 4860. Let's double check that in our finance calculator. Finance 1, TBM solver 1, my number of periods is 20, my interest is 2%, my payment is 200. That doesn't change, none of that changed. I'm just going to now go all the way down to the last variable, PMT, put my cursor over N so it's flashing, end, hit enter, make sure end is flashing, use my arrow keys to go back up to future value, and then alpha, enter, 4860. So this answer key is wrong, ignore it. We're doing it right. So where you see 24.2974, that's the future value of an ordinary annuity. That's the correct ordinary annuity. And I double checked it in my calculator. So C is the correct answer. Ignore that. All right, so we did a lot with future value. Let's take a look now at present value. Rita Grant wants to accumulate a sum of money to pay for graduate school. She wants to invest a single amount today in a savings account earning 10% interest, compounded annually. That is equivalent to investing $10,000 at the end of each of the next 3 years. So she wants to put an amount today that would be like investing $10,000 a year at the end of each of the next 3 years. So we're trying to figure out how much those $10,000 amounts would be worth if we made one lump sum today. So that's the present value, and since the payments are happening at the end of each year, present value of an ordinary annuity, 10%, so this is table 4, 10%, 3 periods. My factor is 2.48685. Multiply the payment of 10,000 times 2.48685. She would have to invest $24,868 today, and that would be the same as if she put $10,000 away at the end of each year for the next 3 years. Guys, you know what this is? This is the lottery. So when you see the lottery says it will pay an annuity of $20,000 a year for 20 years. Yeah, it will. But how do they figure out that lump sum payment? They use present value calculations. They say, what's the present value of those 20,000 annual payments for 20 years, assuming whatever interest rate they're assuming? And they calculate and say, okay, instead of taking $20,000 a year for 20 years, we'll give you this amount right now. They use present value. And there's the present value table. Remember, this was for an ordinary annuity because the assumption was those payments were being made at the end of each year. What if instead she decides she wants to make them at the beginning of each year? Well, now she'll be calculating present value of an annuity due because the payments are assumed to be at the beginning. Okay, so she'll use 10%, 3 years, table 6, 2.73554, or $27,355. That's how much she would have to put in today if she wanted to take $10,000 out a year beginning today. And if you're saying, why would she do that? We're pretending. Why do people do what they do, right? And there's the calculation using the factor directly from the table. Now, if you wanted to do this calculation in your finance calculator, your N is 3, your I is 10, because this is annually. We're going to solve for present value, but we want to put our PMT in as 10,000. Our future value should be at 0. And be very careful. Since we're calculating for an annuity due, I got to make sure my cursor is over begin and flashing. Then I will arrow back up to PV, alpha solve. 27,355. Wow. So now let's take a look at some really funky stuff. You thought that was funky? We're going to kick it up a notch here. Present value of a deferred annuity. So let's take a look at this. This exists when the first cash flow occurs more than one period after the date the agreement begins. For example, at January 1, 2021, you are considering acquiring an investment that will provide 3 equal payments of $10,000 each to be received at the end of 3 consecutive years. However, the first payment is not expected until December 31st, 2023. Interest is 10%. How much would you be willing to pay today to have that opportunity? So there's a picture of what they just depicted. We want to know, what do you pay on 1/1 of 21 to have the ability to get $10,000 beginning at the end of 2023, 2024, 2025. So what we need to calculate first is the present value of the annuity payments. So the present value of the annuity as of the beginning of the annuity period. So there it is. So that's our first step. So the beginning of the first annuity period is 1/1 of 23. That's the beginning of year 1. So present value of an ordinary annuity, table 4. So we're going to say, how many payments are made? 3. What's the interest rate? 10%, 3, 2.48685. Okay, so we're going to take 10,000 times 2.48685. So the value of the annuity as of the beginning of 2023 is $24,868. But that's not what we're asking here. We're asking, what is the value of those 10,000 payments at the beginning of 1/1 of 21? So now we have to calculate the present value of one amount. Okay, so what is that future value worth today? See, there's no payments like there was in 2023, 24, 25 during the time period 1/1 of 21 to 12/31 of 22. We know a future amount, 24,868. How many periods is that for? 2, because there's 2 years from 1/1 of 21 to 1/1 of 23. What's the interest rate? 10%. So we want to go back to the present value of 1. 10%, 3 periods, 0.75131. So we take 24,868, the future value, times the factor from table 2 of 0.75131, and we get, whoa, no, I'm sorry, 2 periods. I used 3 periods. I apologize. It should be 2 periods, 10%, 2 periods. Ay, ay, ay. Yeah, I guess it's getting late in the day. It's Friday today. 24,868 times 0.82645 gives us 20,552. So the most you should be willing to put away today is $20,552 in order to get $10,000 at the end of each year starting in 2023. That's called a deferred annuity calculation. 2 separate calculations. So there it is again. Try to absorb that one. Harry Bird's Chicken Shack agrees to pay an employee $50,000 a year for 6 years beginning 2 years from today and decides to fund the payment by putting money away today in a savings account. How much should they put away? This is a deferred annuity. Present value of a deferred annuity. First, we need to figure out the $50,000 value as of the beginning of year 3, and then the present value of that amount So now this area talks about our financial calculators, which I was trying to stress to you as we were going through. This is a Texas Instrument BA35, and it's very similar to my TI-83. N is for number of periods, or if you're calculating an annuity, number of payments. I is for interest rate. Remember, the interest rate you're using to compound. So if you compound more than annually, you have to change that. Present value is what that money is worth today at time 0. I'm not saying January 1. I'm saying the beginning of the year you're looking at. And that year could be October 15th to October 15th, right? Future value is what the value is worth in the future. PMT represents the amount of a payment in an annuity, that constant dollar amount. And then they have a CPT button on the BA35 for compute button. But on the TI-83s, we have to do an alpha enter. So there's different ways to get your answer. So you would have to consult your owner's manual of your own calculator. So it's just showing you how you can put the numbers in. And I was saying about that. Notice there says minus 200. Sometimes if you don't put a minus in front of a number, whether it be future value, present value, or PMT, it will give you an error. So if you get an error while you're working in your financial calculator, make sure at least one of your numbers has that negative sign on it. And remember, the negative sign is the one you use is the one in parentheses on your number pad. There's Excel. I'm not even going to go into this, but you could take a look. Excel's functions for present value. If you go into the insert, click on function, and choose the category called financial, you'll see present value calculation, present value formulas, future value formulas. Okay, so just to bring that to your attention, and you could explore that. Assume you borrow $700 from a friend who intends to pay the amount in 4 equal installments beginning 1 year from today. Your friend wishes to be reimbursed for the time value of money at an 8% annual rate. What is the required annual payment that must be made to repay the loan in 4 years? So you borrow $700 today. You're going to pay it back in 4 equal installments beginning 1 year from today. So your payments are occurring at the end of each period. Okay, so you know the present value of the money. You know it's an ordinary annuity. And you know it's an 8% annual payment. So what do? We go to our tables. And we go to our present value factor. Present value, ordinary annuity, which is table 4. 8% interest. How many periods? 4. Okay, so we take $700 the amount of the present value today, and divide that by 3.31213, the factor, $211.34. So there's a picture of it. You know what you loaned today, you borrowed today, $700, that's the present value. You're trying to figure out how much you should pay back at the end of each year for 4 years, $211.34. So when it comes to these annuities, there's a little bit more involved than when you just have, I'm going to put one amount away today, how much is it going to be worth in the future? Or I have one amount in the future, what do I got to put away today? Here you have these either annual or semi-annual or quarterly payments that are also occurring in an annuity. Same example, but now your friend wants you to repay the amount in equal installments of $100 per year over a period of years. How many years will it take you to pay it off if you're making the payments at the end of each year and your friend wants to earn 7% annual interest rate? Well, again, you know how much you borrowed. You know you're paying off $700 a year, so now you know your payment. Normally, present value of an ordinary annuity would be calculated by taking present value equals PMT times your factor. Okay, here you know present value and you know your PMT. So if you take 700 divided by 100, you get 7. What you do then is you go to the present value table of an ordinary annuity, 7% column, and you go down it until your factor is 7. And then go across to see how many payments, and it looks like it's 10. And so that's what I was just explaining to you. When you go across that table, you will see it's about 10 annual payments. So if you pay $100 a year to pay off that $700 so your friend earns a 7% interest, it's going to take 10 years. So if you say, I'm going to pay back $1,000, yeah, I know. Determining I when other variables are known. Suppose that a friend asks to borrow $331 today, present value, and promises to pay you $100 at the end of each year for the next 4 years. What is the annual interest rate? Again, you know your present value, you know your payment amount. Divide them. 331 divided by 100. This is the present value of an ordinary annuity because the payments, those $100, are going to be paid at the end of each of the next 4 years. So you know the number of payments. So 331 divided by 100 is 3.31. Go to 4. On your table 4, go down, N is 4, and go across until you hit about 3.31, 8%. Okay, so that's how much interest is being earned by you making $100 a year payments at the end of each year for 4 years when you borrow $331. Suppose that you borrowed $400 from a friend and promised to pay the loan by making 3 annual payments at the end of each of the next 3 years, plus a final payment of $200 at the end of year 4. Well, this is a little different. The first part of this is definitely annuity because it's the same amount of money, but that final payment is not part of your annuity calculation. So, wow, this is crazy, huh? So there's the picture. So what we do is we say 400 equals $100 times the present value of an annuity plus 200 times the present value of 1. We know there's 3 periods for the annuity calculation, but there's 4 periods for that $200 calculation. So we kind of, guess. We try to guesstimate around where it might be. Somewhere around 8 and 9% using these calculations. So if we use PV, let's see if we take 100. It's really just guesswork. Okay, so if you use 9%, determine the factor 9%, 3 periods for a present value of an annuity because there's 3 payments of 100. Get that result. Add to that 200 times the present value of 1, 9% interest column. So you're using your table 2, 9% interest column, because you're guessing now, for 4. Because 4 periods, we're trying to figure out how much that $200 is worth today. So it's somewhere between 9% and 8% is your interest rate. So when you're in those circumstances, it's not as straightforward. So I want to go over one of the most common areas that you do present value calculations, and it deals with bonds. So just to review, a bond is a corporation selling a liability. It's actually getting a loan from the public. And the corporation promises 2 things on the bond. They promise to pay back a face amount at some point in the future, and they also promise to pay interest at certain intervals to the bondholder. So let's take a look here. June 30th, 2021, Famatsu Electric issued 10% stated rate bonds with a face amount of $200 million. So 10% is the interest rate we use to calculate the amount of interest that will be paid to the bondholder. The $200 million is the face amount or par value that is used to calculate the interest. The bonds mature in 20 years. The market interest rate for similar issues was 12%. Interest is paid semi-annually at 5% on June 30th and December 31st, beginning December 31st, 2021, so at the end of the first 6 months. The interest payment is calculated by taking 5% of the $200 million face value. Remember, 10% is annual. Interest payments are happening twice a year, so they'll be paid at 5%, $10 million. What was the price of the bond issue? So we need to determine the present value of this bond. But what's complicated with bonds is there's 2 distinct parts of a bond. And here they are. The first is the future value of $200 million. So what we're saying here is, remember what I said just a few seconds ago. The company promises to pay interest at certain time intervals over the life of the bond, and it also promises to pay a stated or face amount of the bond at the end of its life. So maybe we'll start with the interest. Interest is an annuity payment. Think about it. It's going to happen every 6 months, and it's the same amount. So we're trying to figure out what's the value of those interest payments to a person today. How much are they willing to pay today to have the right to receive $10 million every 6 months for 20 years? Now, when we're determining that, we don't use that stated rate of interest to calculate the present value. We use the market rate of interest. So our N is the number of interest payments, 20 years, twice a year, 40 payments. The interest rate will be 12%, the market rate, divided by 2, or 6%. So we'll go to the present value of an ordinary annuity table because the payments are made at the end of each 6 months. Go to 6%, down 40. The factor to determine the present value of the $10 million payments is 15.04630. So the present value of those interest payments the bondholder will receive is $150,463. So what this is saying is the bondholder is willing to pay that much today to get those payments in the future over the next 40 interest payments. The other component of the bond is that one-time payment at the end of its life, $200 million. That's the future value. We want to know what's that worth today? What's somebody willing to pay today to get $200 million? We use the same N and the same I as we use to calculate the present value of the interest. But we don't use the same table because it's only a present value of one amount. 200 million in the future, what's it worth today? So we're going to go to our 6% column on table 2, go down 40, and our factor is 0.09722. Multiply that by 200 million. So someone is willing to pay $19,444,000 today in order to get $200 million at the end of 20 years. Add those two together, and that's what somebody's willing to pay today to get those interest payments and that bond amount at the end, $169,907. And if you're saying that's a lot less than 200 million, yes it is, and here's why. The market interest rate for every 6 months is 6%. How much is the bond paying every 6 months? 5%. Now, if you had $200 million, would you invest it in this bond and only get 5% interest and pay the full $200 million when you could go somewhere else and get 6%? No. So what does the company do? They sell the bond for less to entice people to buy the bond, and that's how they figure out the selling price. So it's a present value calculation. So please ask any kind of questions you may have, because I know it's kind of squirrely, but that's how we determine the price of a bond. All right, so that is the end of Chapter 5, our discussion on our finance calculations of present value and future value calculations of one sum, and then present value and future calculations of annuities, ordinary and annuity dues, and a myriad of examples to look at. So please work through your homework and post any and all questions.